Good morning, class. Welcome to Introduction to Chemistry. My name is Dr. Christopher, and I will be your instructor for this course. So if you're watching this video, then that means you've already had a chance to look through the syllabus and take the quiz on the syllabus via Talon, which allowed you to access the Unit 1 material. So you should have also watched a short little video on the scientific method, which we will be looking at further in this segment here. So throughout this course, my hope is that you'll be able to get a better understanding of what chemistry is and different aspects of chemistry. And throughout the semester, we'll dive into different topics, different aspects of chemical reactions, and hopefully also make connections to chemistry and how it connects to our everyday lives, right? So one of the goals here is to understand that chemistry is not just a science. It has a connection to everything that we do. And by understanding how to work with chemistry, how to work with chemical reactions, we can have a better foundation to understand what's going on around us. So before we jump into this first unit, though, I just want to remind you that at any time throughout the course, you have questions, comments, need additional assistance, can't find something on the Talon page, whatever it might be, please reach out to me. You can find all of my contact information both in the syllabus and on the Talon homepage in the little welcome widget there. So with that out of the way, let's go ahead and jump right in. So Unit 1, which will cover our first 4 chapters, we'll be looking at chemistry as a science, a little bit about the scientific method, which is what we're going to address directly in today's segment. We'll be looking at measurement and different aspects of collecting measurements and what it means to take a measurement. And we'll be looking at matter and atoms and different aspects of what that means in chapter 3 and 4. So in today's class, we're going to be looking at the scientific method. So before we get into the scientific method specifically, though, let's think about what chemistry is. So chemistry is, of course, a science, and it's that science that tries to understand how matter, or what we might commonly refer to as chemicals, behave by studying how the atoms and molecules that make up that matter behave. So one key aspect here is to understand that the behavior of what we think of as stuff or matter, right, in the bulk sense, is determined by the behavior of the atoms and molecules that ultimately make up that material. Now, we'll address these definitions, these topics of matter and atoms and molecules a little bit later in chapter 3, but let's go ahead and define them right now, just so that we can get that base understanding of what we're talking about. So atoms here are what you might think of as atoms are submicroscopic particles that are the fundamental building blocks of matter. These are also sometimes referred to as the smallest unit of an element. So again, we'll talk more about these specific concepts in Chapter 3, but if we can have these images in our mind, then it helps us, I think, have a little better understanding as we go through all of this material. So, just a couple things here. Submicroscopic, right? When we say that, we simply mean that we cannot see it under a microscope, or at least what we think about as a common microscope, right? We certainly can't see them with the naked eye, and we can't even see them under a microscope. Now, that's an atom, right? Now, a molecule is simply, let me use a different color here, is simply two or more atoms joined chemically in a specific geometric arrangement. Often referred to as well, just like an atom, the smallest unit of not an element, but of what we will learn as a compound. So, atoms and molecules. So, all matter is made up of either what we would think about as atoms or molecules. And ultimately, molecules are made up of atoms, right? So, this is why we often consider atoms as the fundamental building block of matter. So, to summarize here again, chemistry is that science that tries to understand matter by looking at the behavior of the atoms and molecules that make it up. Atoms are those fundamental building blocks of matter, that smallest unit of an element. Molecules are two or more atoms joined together in a specific arrangement, the smallest unit of what we refer to as a compound. And finally, there is nothing that you can hold or touch that is not made up of chemicals, right? Everything, if we think about it, ultimately is made up of atoms or molecules, right? Matter, right? So anything that has volume and space, right, is made up of matter. Now, let's turn our attention to a slightly different topic, and that is the scientific method. So, we discussed this early because it sort of sets the foundation. And it's not a matter that we're going to spend this class utilizing the scientific method, right? We're not going to be working in lab and doing all of these things, but it helps us understand how this information was coming about. And in a more bigger picture, it helps us understand how scientists come to their conclusions, right? How do we view science, right? It's really common nowadays, right, for there to be a distrust of science. But I think we can dispel that a little bit if we understand what science means. How do they come about with that information? How are they working, right? All of these things. And if we have an understanding of the scientific method, then we can have a better understanding of what's going on. So, before you watched this, you watched a little video by Richard Feynman, who was a theoretical physicist. He was giving that lecture at Caltech in 1964 to a first-year chemistry class, right? And it's a very sort of interesting, succinct explanation of what the scientific method is. Now, we won't be using exactly that same terminology, but we can relate to different things that he said in that video to a slightly different look at the scientific method. So let's start out with looking at what is the scientific method. Well, in a big picture thing, it is a method of learning based on observation and experimentation. And typically, we're using this to explain something about the natural world. So, the scientific method is what we refer to as an empirical method. And all that simply means is it utilizes observation, data, and experimentation. Now, when we think about the scientific method, one of the things are this idea of observations, collecting data, and questions, right? So, making these observations, collecting this data leads to questions sometimes. So, the first step in our scientific method, or usually the beginning of the scientific method, is some question or some set of observations that you want to try to explain, that you want to try to answer. Now, in order to facilitate the scientific method, so you now have some observations, you have a question, the first thing we want to do is to collect information that's already known, right? We don't want to reinvent the wheel every time we look at something. So the first thing a good scientist will do is, when he wants to try to answer something, is figure out if somebody else has already answered it, or what other ways have people tried to understand whatever it is that he's looking at. And based on his own observations, their own observations about what they've seen, what other scientists have collected, they will come up with what we call a hypothesis, right? And so hypothesis can be defined in a lot of different specific ways, but basically it is a tentative answer to the question. Now, a good hypothesis must be testable, right? Or sometimes that's called falsifiable. The bottom line is we have to be able to test it somehow, right? We have to be able to say, okay, here's our answer to our tentative explanation or answer to the question. How can we test if this is the correct answer? Now, the way we go about doing that is by conducting an experiment. And so this is where we get back to sort of the heart of that empirical method, right? Using the idea of observation, hypotheses, and testing these hypotheses by using experimentation. And an experiment is simply a controlled procedure designed to test an hypothesis. So, a good experiment, right? What makes a good experiment, or some aspects of a good experiment, is it should be repeatable. So, meaning it has a controlled process, something that's could be done over and over again. And we often will want to conduct multiple trials of an experiment to make sure our results are reproducible, right, or repeatable. The results of an experiment may either support your hypothesis or disprove the hypothesis. Now notice I didn't say it could prove the hypothesis, because we can never prove a hypothesis to be true. We can only support that hypothesis with experimental results. However, we can disprove a hypothesis. And this goes back to, if you remember the Richard Feynman's video when he was talking about the results of an experiment. And one of the biggest points that he makes, right, is if the results disagree with experiment, right? So if your hypothesis disagrees with experiment, it's wrong, right? So the experiments can support your hypothesis, or they can disprove your hypothesis. So the two have to be connected, right? The results of your experiment must support your hypothesis in order for that hypothesis to be correct. Now, the rest of the scientific method involves analyzing the results of your experiment, right? So you do your experiment and you analyze the results, and it either supports your hypothesis, and once your hypothesis, you feel is supported well enough, you've collected enough data, you've collected enough experimental results, you might decide to report these results, publish them in some way, to tell others about your results, which is another big aspect of the scientific method, is that we tell others, we share our results so that they can be repeated or used by other scientists. However, if your experimental results don't support your hypothesis, or they disprove your hypothesis, you can revise that hypothesis and go back to the hypothesis step, come up with a different experiment, or repeat the experiment to see if your revised hypothesis is supported. And so this becomes a circular process, right? So we can either report the results, or we can potentially modify our hypothesis if it disagrees, if our results disagree with our hypothesis. So that's your scientific method. We're going to have some observations. We gather all of the information that we can about our question, our observations. We come up with what we think is a reasonable explanation or hypothesis, or as Richard Feynman called it, a guess. We come up with experiment to test that hypothesis, and then we decide if the results support or don't support our current hypothesis. So now I want to turn our attention to a couple different aspects of the scientific method, or terms that are related to the scientific method, and this is what are known as a scientific law and a scientific theory. So these are often confused, and so we want to try to understand what they really mean. So a scientific law is a brief statement or sometimes a mathematical equation that summarizes, that's not very neat there, that summarizes repeated past observations and predicts future results. One of the big things about a scientific law is it helps us understand what is going on, right? It's a statement of results, right? When we've observed the same result over and over again in different experiments conducted by different people, eventually you get that repeated result. We can use that repeated result to predict future results. And that's when we get what we think about as a scientific law, such as the law of gravity, or in the book, the example that we use in one of the first examples we see in chemistry is the law of conservation of matter. Now, a theory, on the other hand, is a well-established hypothesis or hypotheses, so it could be one or more hypotheses and laws that are combined to provide a deeper understanding of some aspect of the natural world, or physical world, if you will. So, a theory could be a single well-established hypothesis, right, that's been supported with all kinds of information. It could be a combination of hypotheses put together with, perhaps laws that have also been established. And combining these ideas, we try to create an explanation or a deeper understanding, or sometimes we call this a model, to explain some aspect of the natural or physical world. Right? And importantly, right, where a scientific law is just a statement of the result, right? Makes no effort to try to explain why something occurs. A scientific theory is why, just like a hypothesis, right? Tries to explain why something happens, right? The scientific theory is that why, right? Now, scientific theories predict beyond what we currently understand, right? They provide a framework to give for future experimentation, for future understanding of whatever aspect we're trying to understand. So they provide a framework, kind of like example that we're going to get to in a couple chapters, atomic theory, right? Combines several different hypotheses, laws, to try to give us a framework to understand the atom, and can be expanded and supported, right? And this goes back to one of the hallmarks of the scientific method, is that it can be modified, right? Of all scientific thought, right? Whether it's a hypothesis or even a law or a theory, right? They can be modified. Most scientific theories have gone through modification as new experimental results come out. Better experiments, more experiments, right? We can refine and modify these theories to understand them better. And just like we talked about with a hypothesis, a theory can never be proven, right? It can be supported and well supported, but it can never be absolutely proven, right? So if we look at sort of this in the big picture put together, one of the things that we can understand if we look at this is that all of these sort of big three ideas, whether it's an individual hypothesis that we're trying to understand, or a law, or a theory, right? These are all constantly being revised, or constantly being tested, if we will, by more experiments, right? We're constantly trying to refine and confirm what we know, or change what we know based on new results, whether that's a theory, or whether it's a single hypothesis that we're working with, or some law, right? We have these well-established laws that may someday be modified because new experimentations don't agree, or they require us to change it in some way, right? And this, again, is a hallmark of scientific thinking, is that it is not set in stone, even though sometimes people give that impression that a scientific law or theory, these are not written to not be changed. They are written specifically to be changed, right? That's the whole point of the scientific method, is to continually test and revise what we know so that our knowledge continues to grow. So let's just do a quick example here to sort of understand the difference between these three terms, or some of the terms that we've been talking about. So what we want to do is just look at this and classify each of these four statements as either an observation, a law, or a theory. So the first one here, when metal is burned in a closed container, the sum of the masses of the container and its contents does not change. Okay. Well, while it may be tempting to think about this as a law or a theory, because maybe we remember from reading the book that this is an example of a law, conservation of matter, conservation of mass, but this is simply an observation, right? It is a single piece of information, right? This is a single result or observation of an experiment. How about this one? Matter is made up of atoms. This is going to be a theory, right? This is a little deeper understanding, right? It's trying to explain what matter is, or why matter is what it is, right? That it's made up of atoms, right? This is not an observation. We can't directly observe this. And it's not a law. It's not a statement of a repeated observation, right? It's an explanation for something, right? It's a theory. Matter is conserved in a chemical process. Well, this is a law, right? So this is summarizing generally a general summation of what we see up here, right? So this is a specific example of this law, that matter is conserved in a chemical process, right? And this observation is a specific example of that. The last statement, when wood is burned in a closed container, the mass does not change. Now, hopefully this one's pretty straightforward by this point, right? This again is another observation, another example, right? So both of these are examples of the general statement or the general law that matter is conserved in a chemical process, right? So individual examples are observations. A general summary of those would be the law. So, hopefully we now have a better understanding of the scientific method and, some of the different terminology that goes with it.